It's a very non-technical term. So it's a flip over a line. I don't like this stylus. A flip over a line called the line of reflection. Do you not have one? No. Okay. It's a flip over a line of reflection where each point and its image, remember image is the after, each point and its image are the same distance from the line of reflection. A reflection is an example of a rigid motion. Remember, a rigid motion is when it stays congruent. So its position or the way it's facing might be different, but the shape itself should be the same. Rotation, you'll see it noted a couple different ways, but most commonly you're going to see a, what did I say? It uses a small r. So it will look something like this. You have like R over some line. It'll tell you the line that you're reflecting over. And then it'll say like A equals A prime, whatever, okay? So it's going to tell you R, and then it'll tell you what line to reflect it over. Common lines of reflection would be the x-axis or the y-axis. Those are the most common ones that we use. Or you can have vertical or horizontal lines in this form. So x equals a number or y equals a number. If it is x equals, then it is going up and down. If it is y equals, it is going left to right. It's a horizontal line. Or it could be diagonal lines in this form, y equals x or y equals negative x. That's really the only lines that we do. All right, we're going to do these transformations and then we'll talk about the rules afterwards, okay? So translations, you're usually like given the rule, or I might ask you, okay, how did it move? And so write the rule. These ones, it's a little less intuitive, but I think you're going to notice it, okay? So go ahead and graph that little, I'm guessing, yeah, triangle ABC, and make sure you label each point as you go. That's always like the easiest thing to do when you've got translations or transformations. So A is at negative 4, 2. B is at 4, 7. And C is at 5, 1. Pretty big triangle. Okay. Connect it. This is, remember, your pre-image. If you want to label it. This is the pre-image. Meaning before. Okay, now we're doing a reflection. It says R x-axis, so you're doing a reflection across the x-axis, which is this lovely line here. I'm going to highlight it. If you have highlighters, this is a great day to use them. Okay, so you are flipping over that line. If you look back at the top of the page, remember it said that each point and its image are the same distance from the line of reflection. So you're counting squares again today. So you're going to count. This one is 1 above, so when I flip it, it's going to go 1 below. So my image will do in blue. Here's C prime. So remember, you label it with a C and then an apostrophe to show that's the new one. A is 2 above, so when I flip it across, 2 below. So I go 1, 2, and I count 1, 2. So here's A prime. And then B prime is 1, 2, 3, 4, 5, 6, 7. And I go 7 this way. Shoot, I already lost count. Okay, hold on. Down here. Okay, you'll know if you did it right if it looks congruent, meaning that the shape changed obviously where it was in the coordinate plane, but the shape itself shouldn't look any different. Okay, and I'm asking you again to record what are your new coordinates of your image. So A prime is now at -4, -2, because it's left down. B prime is still at 4, but now it's at -7. And C prime is still at 5, but now it's at -1. So my question for you, so if you write those down real quick, there's a rule here. Look at the original coordinates and look at the new coordinates, please. How did they change? What do you notice changed when you did a reflection over the, when you did a reflection over the x-axis? What changed? Yeah, so it's at the bottom. Obviously, it flipped down. But look at your numbers. -4, +2. What did it change to? -4? -2. +4, +7. Now it's +4, -7. What value changed? The y value. Okay, so rules. First one. When I reflect over the x-axis, which is what we just did, the x value stays the same, but what changes signs? The y value. Yeah. Oh, I did 2 different y's there. That's annoying. Sorry. Yes. Because it flips to the other side. So the x isn't changing spots with the y as well. All right, let's do the reflection over the y-axis now. This guy is reflecting over, well, let's graph the points first, sorry. P, Q, R, and S, so it's a rectangle. Here's P. Here's Q. Here's R. Hopefully, and here's S. That didn't look right. Did I do something wrong? Oh, I put P in the wrong spot. Where's it supposed to be positive? Oh, no.
So if I don't have my bag.
Okay. Okay, one sec. You know what I did wrong? You're going to change this for me to make it work, because otherwise it's not a rectangle. Change it to +1, +2. Sorry. Put P in this spot. That was a rectangle. Otherwise, it's not a rectangle. Yeah, that was not going to work. Okay, if I'm reflecting over the y-axis, then I'm going this way. I'm reflecting over that line, so then again, you're counting. You're trying to flip it over the other direction, and you're counting how far away it is from the line of reflection. Here. Okay, so now you're counting. P is 1 away from this y-axis, so go 1 the other direction. So that would put P prime right there. Q is 1, 2 away, so go 1, 2 the other direction across the y-axis. R is 1, 2, 3, 4. They're 8. So I'm going 8 the other way. Make sure you put apostrophes in all your new letters. This is 7 away, so it's going to go 7. That away. It should still look like a rectangle, but now it's been reflected over. And I'm going to quickly jot down the 4 new coordinates, okay? So P prime is now at -1, +2. R prime is at -8, +3. Q prime is at -2, +5. And S prime is at -7, 0. So again, I'm asking you what changed. Yeah, your x values changed sign. So it was +1, +2. Now it's -1, +2. It was Q was 2, 5. Now it's -2, +5. So the x values are changing signs. So if I'm doing a reflection over the y-axis, And this should be something you should be able to notice on your own, that if I reflection over the y-axis, then my xy will become, okay, this stays the same, but the x value changes sign. Again, you got a triangle, JKL. 1, -1. For J, K is at 2, 3. And L is at 3, -2. Is that really what it looks like? Beautiful. Okay. So it's kind of a skinny triangle. Okay, we are reflecting. My J is in a weird spot. Sorry. You're reflecting over the line. It says R and then X equals 4. Okay, so again, you're going to see me highlight it. Okay, X equals 4. This is a vertical line that goes through the x-axis. So I'm here at X equals 4. You can maybe kind of, I'll actually do it in. But then I draw a line down that, okay? So I'm saying the X value should always stay at 4. It's a vertical line. If you remember this is a review from Algebra 1. So this is the line X equals 4. I'll darken it a little bit if I can. That's the line it's reflecting over. It's a vertical line. And so then again, you're counting across that. So L is 1 away. L goes 1 the other way. So that would put L prime here. J is 2 away. 1, nope, 3. Just kidding. 1, 2, 3. So 3 the other way. You can probably do this yourself. You're just counting squares. And K is 1, 2. Squares away from that line. So 2 the other way. Please pay attention. Most common mistake that I see is that my students see X and they're like, oh, I'm graphing the x-axis, or I'm reflecting over the x-axis. No, you're reflecting over the line X equals 4, this line here. Okay? We're not going to record the coordinates because of the sake of time. This one doesn't have a rule anyways, so you're just going to have to do it by hand. And then you can try the next one. So we're graphing MN and P, so another triangle. Okay, so now there's a skinny little triangle here. Kind of at the bottom like that. And you're reflecting over the line y equals -5. Okay, so I go to the y value, or the y-axis at -5, and it's got to slice through that. So it's the horizontal line. And I'll kind of darken it because it's a little hard to see. Or maybe I'll do it in green. It's this horizontal line that goes through where y equals 5. That's what you're reflecting over. So now again, you're just counting. How far away is it from that line? Flip it over to the other side. N is 1 away, so it goes 1 the other direction. You hopefully get the gist by now. Prime is up here, and P. Again, everything we're doing is rigid transformations right now, and so that means that your shape should still look the same size and shape. We're not going to record the coordinates because ain't nobody got time for that. Okay, so we're going to first, on number 17, you can go ahead and graph your 4 points, and then we'll talk about how to graph the line y equals x. Here's G. This is a rectangle. Cool. H. I. J. All right, it should look something like this. It's a rectangle in the bottom right quadrant. It is reflecting over the line y equals x. Okay. Again, review from Algebra 1. If I have the line y equals x, that is the line that has a slope of 1 and a y-intercept of 0. Okay? So there's your review from Algebra 1. It's the most basic vanilla ice cream kind of diagonal line you could possibly have. So you're going to start it at 0, go up and over. Up 1, right 1, up 1, right 1. You're just graphing it's the vertical line, or it's a diagonal line that goes through the origin and is positive, okay? So there's y equals x. It'll connect corner to corner because we got a square. So you should graph that line. I'll zoom in now. Okay, and the reflections on this one are kind of tricky. So you can count, but you can't count like normally, okay? Because if I wanted to count, what I actually have to do is I'm saying like G is like 3 away, but it's 3 up, and because it's diagonal, I have to go 3 then over to the left. That would put G prime right, here. You can do it by hand if this makes sense to you, like H, oh, it's a tricky one. H is 1, 2, 3, 4, 5, 6, 7, 8 away, so then it goes 8 this direction, has to turn. And so it's up here. I think I did that right. Yeah. This is kind of tricky. So that means that G prime is at -1, +2. H prime is at -1, 1, 2, 3, 4, +7. Okay, I want you to see if you can figure out the rule right now, because for some of us, this is going to be really difficult, but the rule might be a lot easier. Look at the coordinates. G originally was at 2, -1. Now it's at -1, 2. H was at 7, -1. Now it's at -1, 7. What happened? They flip-flop. Yeah, so we're going to write rules out to the side here. Rules. If you are reflecting over y equals x, which is the positive line, then the rule is that xy flip and become yx. So I think for some of us, it's going to be easier to figure out the coordinates first. So if I is at 7, -4, then I prime is at, flip it, -4, 7. Okay, now I'm going to graph that. If J was at 2, -4, flip it, it's now at -4, 2. And so I put these rules on your paper today. Okay. You can also do it by what I showed you the first time, by counting. But again, I think sometimes these rules are easier. So you could have done it by counting, like J is 1, 2, 3, 4, 5, 6 away, so I go 1, 2, 3, 4, 5, 6, that way. That's totally fine. But you should be able to notice the rule for me that they flip-flop. Okay, next one's exactly identical, except that it's the negative line. So it is reviewed from Algebra 1. This is the line that has a slope of -1 and it has a y-intercept of 0. So let's graph the points first. We're going to make this a -3, so it turns out a little nicer for us. So make this 3 negative for me. Okay, so S is at -1, -6. T is at 0, -3, please. And U is at 3, -4. So that'll put it, yeah, down here. Should have moved my T. Not very pretty. Okay. you are graphing over this diagonal line that starts at 0, but then goes down 1, right 1. Okay, so it looks like this. And again, you can count. Like if you'd like to do it by counting squares, that's totally fine. But you got to remember that if it's a diagonal line, you got to turn. So like if t is 3 away, I can't just go 3 right across. I have to turn and take it go up. So t prime would put it up here. You do the same thing for u. It's 1 away, it goes 1 the other direction. Or you can use the rule. Okay? So the rule for these ones, we'll write down what these are. T prime we already did is now at positive 3, 0. U prime is at positive 4, negative 3. So this one's a little interesting. Look at U. It was 3, negative 4. It flipped, but then what else did it do? The signs changed because it's negative. So because you're reflecting over a negative line, the signs will also flip. So we're going to do this one with a rule. S prime, I would flip that and change signs. So that would make it become 6, positive 1. So write the rule out to the side. Here's the rule for flipping over a negative line. X, Y, hold on, becomes, it flips, yes, but also changes signs. So negative y, negative x. So you see all of these flipped and changed signs. Negative 1, negative 6 became positive 6, positive 1. So I'm going to graph that one as well. You can do it by counting squares, but I usually see more mistakes on this. So just be careful if you're doing that and make sure that you're not just going straight across. You got to turn. I will highlight it so you can see. All right, this guy is, what is this one? This is the negative line. This one goes over. It's not drawing. Go. Hold on. Delete my line. Okay, and then the last one, what on earth? Okay. Oh, okay. This guy. Okay, so please notice the difference between y equals negative x and y equals positive x. Number 20 is over the line y equals negative x because it's going down from left to right. It's a negative line. Number 22 reflects over the line y equals positive x. It's going up from left to right.